Okay, so this example kind of connects a lot of the different things that we've been doing with right triangle trig and angle rotations in our coordinate system. And so what we're dealing with here is we want to find a point on a circle that intersects an angle that rotates 150 degrees, and the circle has a radius of 5. So I'm going to go ahead and draw this angle real quick. We know that this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. And so my rotation of 150 is going to be approximately right here. And so what I'm going to do is we have a radius of 5, and so I'm going to draw probably a pretty bad circle here, but this dashed line here represents the circle. Okay, so we want to find the location of this point. So in order to find the location of that point, we need our x distance and we need our y distance. And this, which is the hypotenuse of the triangle, is also the radius of the circle. And so we have a 150 degree rotation. Okay, so now we have our angle rotation of 150 degrees. And so in order to find the information about this triangle, I need to find the reference angle here, which is 30 degrees. And this is a right angle, and so because this is 30 degrees, that makes this 60. So it's a 30, 60, 90. Okay, but here's one of the issues that we have. It's not going to be 1 root 3 and 2 because the radius of this guy is 5. So I know my radius is equal to 5. So what I'm going to do on the left side of this picture is I'm going to do two things here. There's two different ways to find this. And I'm going to go through one of the ways that's more of a trig way to do it, and then we'll talk about a different way that is relative to what you maybe have discussed in your geometry courses. Okay, so I am going to say that sine of some angle is equal to the opposite over the hypotenuse. Okay, so opposite over the hypotenuse, which means that's going to be y over r. So this is the same as opposite because our y value is our opposite and our r value is hypotenuse. So let me just put the information that I have in. Sine of 30 degrees is equal to, not 5, y over 5. So if I cross multiply, 5 times sine of 30 degrees is equal to y. So here's what we do, is this sine of 30 is a common value that you're going to see all the time. Okay? So what I do for sine of 30 is kind of in a separate piece or some separate notes. What I'll do is I'll be, okay, I'm going to draw 30, 60, 90 in perspective of where the angle is in my coordinate graph. So look at the perspective. Both angles look the same. So this is 30, this is 60. A 30 degree angle, this is 2, this is root 3, negative root 3 because of the perspective, and this is 1. So sine of this angle would be opposite over hypotenuse. So if the radius was 2, it would be 1/2. So sine of 30 degrees all by itself without any change in the radius is going to be 1/2. So I go back to my problem, and I know sine of 30 degrees is equal to 1/2. So I plug that in for sine, and so y is going to equal 5/2. And by that, I'm going to write sine up here, so we know that that's our sine value. And I can do the same thing with cosine. So cosine of an angle is equal to the adjacent side over the radius. So the adjacent side is x, the hypotenuse of the radius is r, and I can solve for x by multiplying both sides by r. So r times cosine of theta is equal to x. So x is equal to 5 times cosine of theta. Well, what's cosine of theta? Well, here was sine. Cosine is adjacent over hypotenuse. So cosine of the angle is going to equal root 3 over 2, and that's a negative. So I substitute the negative root 3 over 2 in for the angle, and I get x is equal to negative 5 root 3 over 2. And those are my two values. Oop, not what I wanted to enlarge. So this point right here has a y value of 5/2 and an x value of negative 5 root 3 over 2, 5/2. And that is our point. And so that's how I can find that point on that circle by using right triangle trig. Okay. Now the other way to do it, I'm going to put a little box here. And there was a previous video that kind of worked through this, but the other way to find it is I'm going to draw my right triangle in perspective. And this is 30 degrees and this is 60 degrees. And the ratios of the sides of the triangles are, this is always twice x, this is always x, and this is always x root 3. So I know the radius is 5, and so what I do is I take this and create an equation. 2x is equal to 5, so x is equal to 5/2. So what that allows me to do is now I can just take this piece for x and substitute it into these pieces. So this part of the triangle would be 5/2, and this part would be 5/2 root 3. Now the only thing I have to worry about is right here I have to consider the perspective of the triangle and know that this guy's going to be negative because we're in the second quadrant. And we get our y value and we get our x value. So that's a slightly different way to do it. So here's a trig way, and here's more of an algebraic way where we use the idea of the ratios of the sides of the triangle. And that's how we can find the point on a circle. So the whole idea of these reference angles, drawing right triangles, is so we can find a point on a circle in a coordinate system.